Write the missing numbers in the sequence. So we have 6,742,000, 6,842,000, 6,942,000. So what we need to look at is the digits that have changed and the digits that stay the same. So we can see that it's our 100,000s digit that's changing. So we can highlight our 100,000s digit and the digit to the left because the 5 digits on the end stay the same. So if we look at only our millions and 100,000s digits, we have 67, 68, 69, so we will have 70. That's 7 as our millions digit, 0 as our 100,000s digit, and then we'll have 42,000 on the end because those digits stay the same. And that's because in this sequence we're adding 100,000 each time. So our 10,000s, thousands, hundreds, tens and ones will stay the same. And to find this number here, we can think the number before 67 is 66, so that's 6 as our millions digit, 6 as our 100,000s digit, and again the 42,000 will stay the same. So we have 6,642,000. What is 10% of a half? So 1 whole is 100%, and that means a half is 50%. So we want to find 10% of 50%. 10% is the same as 1/10 because a percentage is a fraction with a denominator of 100 and 10 hundredths simplifies to 1/10. So we need to find 1/10 of 50. That's 5 because if we have 5% 10 times, that gives us 50%. So 10% of a half is 5% because 1/10 of 50% is 5%. Now, what percentage of 20 is 19? So as a fraction, we can write 19 out of 20 as 19 over 20, but a percentage is a fraction with a denominator of 100. So we can find an equivalent fraction. 20 times 5 is 100 and 19 times 5 is 95. So that's 95%. If you get 19 out of 20 in a test, you've got 95%. This sequence of numbers goes up by 40 each time. So we have 40, 80, 120, 160, 200 and so on. So we have multiples of 40. This sequence continues. Will the number 2140 be in the sequence? Explain how you know. So we need to work out whether 2140 is a multiple of 40. So whether this number is in the 40 times table. And we can work that out by dividing it by 40. So if we get a remainder, then it's not a multiple. We have a division with end zeros, so if we cancel those, we can work out 214 divided by 4, and that gives us a remainder. So 2140 divided by 40 is 53, remainder 20, because 214 divided by 4 is 53, remainder 2. So because we get a remainder, it will not be in the sequence. All numbers in the sequence are multiples of 40, and 2140 is not in the 40 times table. Another way to work that out would be to spot that the number 2000 will be in the 40 times table because 20 is in the 4 times table, so 2000 will be a multiple of 40, but 140 is not a multiple of 40, so that means 2140 will not be in the 40 times table. For each of these points, put a tick to show if it is inside the square. So first we have the coordinates 50, 70. So remember, the first coordinate is the x coordinate, and because we have 0 here and 80 here, 50 will be in line with about this point here. Then the y coordinate is 70, so if this point is 60, 70 will be just above that, so our point will be at about this point here, so we'll be outside the square because 70 is larger than 60. Now we have 60 minus 30. So an x-coordinate of 60 will be at about this point here, and a y-coordinate of minus 30, if this is 0 and this minus 40, minus 30 will be about here. So we can imagine that those points will cross at about this point, so the point will be inside the square. Now minus 10 as our x-coordinate will be inside the square because that's between 0 and minus 20, and then 50 as our y-coordinate will be inside the square as well because that's less than 60. So we'll have our point at about this point here, so that will be inside the square. And finally we have minus 30, minus 30. So an x-coordinate of minus 30 will be outside the square, because if this point here is minus 20, minus 30 will be to the left of that. And then a y-coordinate of minus 30 will be inside the square, but not if the x-coordinate is minus 30 as well. So this point here will be outside of the square. K stands for a number. Complete the number sentences below. One has been done for you. So 5 more than k is k plus 5. That means 2 less than k is k minus 2. Now we need to find 3 more than twice k. So twice k is 2 times k, which we can just write as 2k, but we want 3 more than 2k, so we can write 2k plus 3. Now we need 6 more than half of k, so we can write half k plus 6. The shape ABCD is a rectangle. BD is parallel to EF. Calculate the sizes of angles X and Y. So we need to find these angles here, but with angles problems we won't be able to find the angles straight away. So what we need to do is find out as much information as we can from the diagram. So we know that this angle here is 55 degrees, and we can see that we have a Z angle. So this angle will be 55 degrees as well, because angles inside the Z will be the same size. Now here we can see that we have angles on parallel lines. This little arrow tells us that this line is parallel to this line, and we're told that they're parallel in the question. So if this angle is 55, this angle here will be 55 as well. So now we can work out angle X, because we have angles on a straight line, and angles on a straight line add up to 180. So we have 55 plus X is 180, and that means X is 125, because 180 minus 55 is 125. So now we can spot that this will be a right angle, and angles in a right angle add up to 90 degrees. And we know that it's a right angle because we're told that the shape is a rectangle, and the angles in a rectangle are all 90-degree angles. So 55 degrees plus this angle here need to total 90 degrees. So this angle here is 35, because 90 minus 55 is 35. So this angle here will be 35 as well, because again we have angles on parallel sides, on parallel lines. Now the other way to work out that this angle will be 35 is to spot that this angle here is a right angle, so 90 degrees, and then angles in a triangle have to add up to 180. So we have 55 and 90, that's 145, and if we subtract the total of these two angles, so 145 from 180, that gives us 35. So now for angle Y, we have angles on a straight line, so we can subtract 35 from 180, and that gives us 145 degrees for angle Y. A sequence starts at 500 and 80 is subtracted each time. So 500 minus 80 is 420, minus 80 is 340, and the sequence continues in the same way. Write the first two numbers in the sequence which are less than 0. So 340 minus 80 is 260, minus 80 is 180, minus 80 is 100, minus 80 is 20. So if we subtract 80 from 20, that will take us to below 0. From 20, on a number line, we can subtract 20 to get to 0, but if we want to subtract 80 altogether, we need to subtract another 60, because subtracting 20 and then 60 means that we've subtracted 80 altogether, and 0 minus 60 is minus 60, so that's the next number in the sequence, but we want the first two numbers. So we can work out minus 60 minus 80. That's minus 140, because from 0, if we're on minus 60, we've already gone back 60. So if we go back another 80, that's going back 140 altogether. So that gives us minus 140. A cuboid has a square base. It is twice as tall as it is wide. Its volume is 250 cubic centimeters. Calculate the width of the cuboid. So we calculate the volume of a cuboid by multiplying length times breadth times height. So we need to think what times what is 250. Now we know that it's a square base, so these two numbers will need to be the same, and we know that it is twice as tall as it is wide, so this number will need to be twice as large as our other two numbers. So what we can do here is use trial and improvement. So if the base was 1 centimetre, we would have 1 times 1, and then the height is twice as large, so the height would be 2 if the width was 1. But 1 times 1 times 2 is 2, not 250. So we need to try numbers which are much larger. So let's try 10 times 10 times 20. That way, these two numbers are the same, so we have a square base, and we have 20, which is twice as much as 10. Now 10 times 10 is 100, times 20 is 2,000, so that's too many. So let's try something in between. If we have 5 times 5 times 5, so a base or a width of 5 and a height of 10, 5 times 5 is 25, times 10 is 250. So we have a width of 5 centimetres. We have a square base because this width is 5 and our breadth is 5 as well, so that's a square. And we have a cuboid that is twice as tall as it is wide because 10 is twice as much as 5. 5 times 2 is 10, so 10 is twice 5. Draw 2 more lines to complete the triangle with an area of 10 centimetres squared. So the area of a shape is the amount of space that it takes up, and we can calculate the area of a triangle by multiplying the base by the height and then dividing by 2. So we can see that these dots are 1 centimetre apart, so the base is 5 centimetres in length. So we need to think 5 centimetres times whatever the height is divided by 2 must be 10, because the area needs to be 10 centimetres squared. Now 5 times 4 is 20, and 20 divided by 2 is 10. So the height needs to be 4 centimetres. So if we go up 1, 2, 3, 4, we can draw a line to this point and then connect the points to make a triangle. But the triangle doesn't have to be a right-angled triangle like we've drawn here. We could draw a triangle like this, because we still have a base of 5 and a height of 4 centimetres. We could have a triangle like this or this, so there are lots of possible answers for this question. We could even draw a triangle like this. That still has a height of 4 centimetres, because from the base we need to go up 1, 2, 3, 4 to get to the point at the top. The diagram shows 2 shaded equilateral triangles. Calculate the size of angle X and angle Y. So we need to remember that the angles in an equilateral triangle are always 60 degrees. That's because in a triangle the total of the angles is 180, and with equilateral triangles all of the angles will be the same size. So we can remember that angles in a triangle add up to 180, and that helps us find this angle here, because we have a triangle and we know 2 of the angles, so we know that this angle is 40 and this angle 55. So that's 95 altogether, and if we subtract that from 180, we get 85 degrees for this angle here. So now we can work out angle X, because angles around a point add up to 360 degrees. And we have angles around a point here because we have a point, and then whichever direction we move in, we get to an angle. So we can work out 60 plus 60 plus 85, so the total of the angles that we have, and that's 205. And if we have 360 minus 205, that gives us 155 for angle X. So now we need to find angle Y. To do that, we need to know what this angle here is. But the only way that we can work this out is by finding this angle first. So here we have angles on a straight line, and angles on a straight line add up to 180. So we have 40 and 60, so that's 100, so we need another 80 to make 180 degrees on a straight line. And if we know that this angle is 65 and this angle 80, we can work out this angle here, because we know that angles in a triangle add up to 180 degrees. So 80 plus 65 is 145, and if we subtract that from 180, we get 35 degrees for this angle here. So now, again, we have angles on a straight line. We know that this angle is 35 and this angle 60, so that's 95 altogether. And if we subtract that from 180, we get 85 degrees for angle Y.